So I'm going to go through an example of a statement for which we have to generate a truth table. So the statement is as follows. So we have P and Q, or not P implies Q. Okay. So here we have this connective. It's the AND symbol, known as the conjunction of statements P and Q. This here is the OR symbol. It's known as the disjunction of two statements. This is the negation of P. And this is the implication. So we have 1, 2, 3, 4 connectives, or 3 connectives and 1 negation symbol. So we have to iterate columns of our truth table. So let's start with the possible truth values of both P and Q. P, Q, okay, so the good order to start with is when both truth values are true. Then we go true, false, false, true, false, false. So the next one is, let's go with the negation of P. It's always a good idea to have that as our next column, because that's the statement we're then going to combine somehow with, or connect with statement Q. Sorry, false, false. So the negation of P is, so wherever you see true, you write false for P, and wherever you see false for P, you write true. Let's go back to this statement, the conjunction of P and Q. P and Q. Oh, that's terrible. So the conjunction of P and Q is only true if, well, wherever you see truth values that are both true for P and Q. So we see that only in the first row. So we put a true here and false everywhere else. And next we can see this bit of the statement, and we're ready to combine that now. So not P implies Q. Okay, so the way the truth values work for an implication is that if you have, say, in general, A implies B, the truth value is only false when you have the truth value of A being true and then the truth value of B being false. So when you have a false implication, you have a false truth value. So basically, if you see a true and then a false, that leads to a false. Elsewhere, it's true. Okay, so I can only see, where do I see that? So here we have column not P, and here we have column Q. So if you first see a true, then a false, it's a false. I see a true, then a false here. And that's a false. So everywhere else is true. Okay, next, well, now we can combine everything together to form the entire statement. So we have P and Q, or not P, implies Q. So we're using the disjunction of these two columns. So the truth value is going to be true whenever at least one of the truth values of either statement is true. So since they're both true, it's true. Since one of them's true, it's true. One, again, same here. And here we see both are false. Hence we have a false truth value for this column. Not for this row, sorry, and column. So I guess, yeah, that's the truth table. So let's follow it up just quickly with a question that looks at this truth table. And the question is the negation of P imply Q? So this symbol means equivalent. Is it logically equivalent to the statement entirely? P and Q, or not? P implies Q. So two statements are, we could verify the logical equivalence of two statements by looking at the truth values in their respective truth table, and looking at those columns. And if the truth values are the same for both columns, then it guarantees logical equivalence. So let's just look at the left-hand side, which coincidentally forms part of the entire statement. If we look at that, we have true, 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 then false. And then if you look at the right-hand side and the corresponding column for that, in the truth table, we have the same sequence of truth values, true, 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 then false. So since they're the same, they correspond, we can conclude that they are logically equivalent. So we could just say, yes, each of the truth values are the same. Let's say across the four rows. And that's it for that.